in the previous code, we had written we try to implement the concept that we wanted to teach the machine to identify the amount of tilt that is present in the handwritten data set, right? Identifying that and then correcting that, right? So out of which we had some issues with the correction part, right? It was not being uh, clearly seen, right? But now I think I have resolved that issue. All right, let's quickly see that. Okay, so uh, fine. So let's try to run the code one by one. So the first section is to clear, close, and clear the command windows, right? Then we'll read the data, right, into the X train, the data, and the Y train is the class, right? And it's not a class actually; it's a regression problem. A single number will come over there. Y train will be the angle corresponding to that. X test is a test data corresponding to that. You have some Y test. Okay, so which is the expected angle of tilt. All right, so let's run that and see. So we can see that X test, X train, they're four-dimensional data because three dimension for an image plus one more dimension, their location. Okay, X train and X test are of that type. And then we can see that the Y test and Y train are corresponding to each data present in X test and X train. It's going to tell us about the various angles of tilt. We can see that, right? Various numbers do exist and they are up to 5,000. So maximum is 5,000. Okay, right. So that's the data. Then let's define the, okay, we want to visualize that next. So we defined, right, the various parameters. I wanted to see 30 different numbers in my 5,000 data set. All right, then I create using a rand perm function, right? Between 5,000, 1 to 5,000, I create 30 numbers in the array, which is index. So let's look at the index. You can see that it is a 30 numbers, randomly generated numbers. I wanted to have 30 different plots. So, right, you can see that 30 different numbers have been created by the rand perm function. Okay, so after that, now we'll create a figure. So that figure will bring the plot, right, of 30 numbers, right? So 6 rows, 5 columns are what we are expecting. So you can see that some of the numbers have some amount of tilt in them, right? And others, few of the numbers are actually properly written, right? And we can identify that the tilt can be towards the left or towards the right, right? Whatever is properly written, vertically, normally written, you can call it as a tilt is equal to 0. Others have various types of tilts. What is the amount of tilt? It has to be identified by the regression, right? So in the next step, we try to visualize the amount of what is the range of rotation we have by using a histogram. Right? So we can see that there is a histogram, and this histogram shows various angles in in the following ranges. Right? So starting from minus 45 till plus 45, and the number of entries we have also we can find out like this. Okay, so that's what is the details of the data. So data set is ready and I don't have to make any modifications over there. Simply we will be defining the layers options and we'll train the neural network. Okay, so input is image input layer because our data set is in images, right, of the size. I don't know the size, so I'll use the exit train. Whatever is the size, I'll find out using the size function. Okay, so that is the size of the image input layer, right? And you can see that we are using convolution layer, batch normalization, ReLU, and a pooling layer. So this is repeated, right, four times. Okay, after that we use a dropout, then fully connected to get an output, and regression layer because we are trying to perform a regression here and we are not classifying anything. Then go for a training option, right? In the training option, we are using the batch size of 64, mini batch size. Up to 100 epochs, we are restricting, right? And initial rate is 0.001. And after, say, 50 iterations, I want to drop it down to 0.1. All right. Then we'll do the validation as well, right? Validation frequency is 128. I kept 128, but I just want to reduce it to say smaller number. Every time training happens, I want to go with this. Okay. Then the want to visualize the plot as well as the verbose. Then we'll go for the training part. Okay. So training has started. Yes, Tej. 17. No, actually, in mine it is right now. It is running at 76. Maybe. Oh, on your screen. Okay, okay. Let me check one thing. I'll stop sharing and I'll share again. Can you see now? Check. Just one second. You can see. Right. So we can see that the training is over, and after 100 iterations, sorry, I'll share again. So just a second. Right. So after the 100 iterations, we can see that there has been a convergence, and also the training resulted in this. Okay, after 7,800 iterations and 100 epochs, we can see that the RMSE is 1.89, 1.8019. Okay. So after that, now we'll go for a prediction part. And for a prediction, if you remember, we tried to make sure that there is a threshold that we define, and the threshold value is 5. This is used like, okay, if at all the predicted error is plus or minus 5 of the actual angle, then we'll consider that as a correct answer. Okay, that's why there is a threshold. So you can see that the threshold has been used. So correct answers are only those answers where the prediction error, that is a white test minus the predicted answer. So that's what we call this as error. If error is lesser than the threshold value, absolute value of the threshold, sorry, absolute value of the error is lesser than the threshold, we call it as a correct answer. So accuracy is nothing but number of correct answers divided by the total number of y tests. How many number of them for the test. So as you can see, when you run that, we are getting 78%. Okay, right. Then we wanted to visualize using a graph here, and we'll see the graph. Graph comes like this, right? So machine has learned a straight line, red colored line, right, which is an approximation or a straight line fitting the data points. Okay, so that is also done. Then in the next part, we wanted to visualize or for, okay, let's create the corrected answer, because when the machine can predict what is the amount of tilt that is present in any test data set, it should be able to correct that as well, right? So for that reason, we had written a part of the code like this, which actually makes a prediction. And restored image is a new array that holds the rotated image by whatever is the predicted angle, right? You correct it. Okay, and I wanted to use this as a method, and I just wanted to have a crop so that the size of the corrected image matches to that of the original image. Then we'll plot. So in this plot we had some issues, right? Now we try to correct that. Okay, so just check, right, whether you can see that. So look at the first number, that is a 4. Okay, 4 has been tilted here on the left. On the right side you can see that it is corrected, right? So there are some issues, like you can see the 1 which is here, right? So this one you check, which is not corrected by that much, right? It's not a proper answer. But the 6 which is here, right, I can see that it is corrected, right? So since we have only 78%, right, as a regression rate, right, rate of accuracy, right, that because of that we have some issues, right? This 9 also you can see it's not properly corrected, whereas, right, some of the numbers, this 7 you can see, right, 7 has been corrected properly. This 3 which is tilted to right has been corrected, right, and so on. Many of them, right, have been corrected, right, over here. Okay, so that is the digit correction code, right, by performing what is called as a regression.